Okay, this is lesson 0.2 of our review unit, and this is function notation. First, what's a function? Well, a function is a relation that we talked about in the last review lesson, but it's a very specific type of relation. It's a relation in which each element in the domain, so that means every x, has only one corresponding element in the range y. So for example, we have function notation versus an equation. When we use function notation, we might write evaluate f of x, so the function of x, when that's equal to 3x squared minus 4 when x is negative 1. If we were talking about an equation, we'd have the equation y equals 3x squared minus 4 and be asked to evaluate when x equals negative 1. It looks the same, and the answer is the same, just the way it looks is a little bit different. When we use function notation, we replace the x with negative 1, so it looks like this. The function at negative 1 is 3 times negative 1 squared minus 4. And if we follow BEDMAS, negative 1 squared is 1. 1 times 3 is 3. Minus 4 is negative 1. So we end up with the function at negative 1 is negative 1. The function at negative 1 is negative 1. Now, if we were evaluating an equation, we'd do the same way. We just have y equals 3, negative 1 squared, minus 4. We know the answers to these. And negative 1 squared is 1 times 3 is 3, minus 4 is negative 1. We end up with y equals negative 1. Well, what's that mean? It means when x is negative 1, y is negative 1, which means that negative 1 is a point on the graph. Or we could say negative 1 is the ordered pair. Either way. So let's continue working with function notation. So if I ask you to evaluate each function, we're just replacing the x with the number and evaluating. So our first one, we've got 2x minus 4 all squared plus 5, and we want to know what x is, when x is negative 1. So we write f at negative 1, and we say 2 times negative 1 minus 4 squared plus 5. And then we follow BEDMAS. Negative 1 times 2 is negative 2, minus 4 is negative 6. Negative 6 squared is 36, plus 5 is 41. I'm going to leave B for you. I want you to evaluate G of 2. You can pause the video and try it now, or you can try it after the lesson and check your answer on the course website. I'm also going to leave 2 of example 2 for you to try. H of 2, given that h is 5x squared minus 3, and h of negative 1. You can, again, pause the video and try them now, or you can wait till after the lesson and give them a shot. I'll spoil the answers. H of 2 should give you 17, and h of negative 1 should give you 2. So give those ones a shot on your own. I want to focus on C and D because they look a little different. C says 2h of negative 3. What's this mean? Well, this means that we want to evaluate h of negative 3 and then multiply the answer by 2. So I'm going to create a big square bracket. And I'm going to put the 2 in front. 2 times whatever h of negative 3 is. Well, what's h of negative 3? Well, that would be this function with negative 3 put in. So that would be 5 negative 3 squared minus 3. This is one way to do it. Alternatively, you could figure out what h of negative 3 is first and then multiply your answer by 2. But based on how this is written, I would need you to express it like this. And now we just have to do a little bit of math to come up with our answer. Negative 3 squared is 9. 9 times 5 is 45. So we get 2. 45 minus 3. 45 minus 3 is 42. And 2 times 42 is 84. So 2 times h of negative 3 is 84. H of 2 minus h of negative 1. Now if you notice something special about this,
Vanessa Berryman, can you dial extension 190? Vanessa, dial extension 190.
now if you notice something about this, you'll notice that h of 2 and h of negative 1 are the questions that I just did previously. So we just need to subtract those answers, and we get 15, and that would be the correct answer. So it would be very fair game for you just to write 17 minus 2 equals 15 because you've already done the math. Now if you didn't notice that, you'd actually need to solve what h of 2 is and what h of negative 1 is and subtract them. So what's h of 2? Well, I'm going to put it in square brackets. H of 2 would be h with 2 replacing x. So 5 times 2 squared minus 3. And we'd be subtracting h of negative 1. So again, function h to negative 1. 5 times negative 1 squared minus 3. Now we have to do a little bit of math. 2 squared is 4. 4 times 5 is 20. Minus 3 is 17. Negative 1 squared is 1. 1 times 5 is 5. Minus 3 is 2. We end up with 17 minus 2, which is 15. So that's working with function notation. One last thing about functions. When you have a graph of functions, in order to show or demonstrate that it is a function and not a relation, we have a test, and it's called the vertical line test. When is a relation a function? Well, a relation is a function when it passes the vertical line test. How do we do the vertical line test? Well, let's do a review of an example that passes and an example that doesn't. Now to do this, we're going to create a table of values and graph a relationship. We are going to start with the absolute value of x. So this is the absolute value function. If you remember, absolute value means take the number and express it as a positive. So if we have negative 3, the answer would just be 3. If we have negative 2, it would be 2. Negative 1 would be 1. If the number is 0 or positive, it remains the same. So if we were to graph these points, negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. We end up with a graph that's 2 straight lines. End up with a graph where I should be using a ruler. Looks like this. So to see if it passes the vertical line test, we just have to draw some vertical lines and ensure that the vertical line only hits our function once. If it hits it more than once, if it hits it twice, anywhere on the graph, it fails the vertical line test and it is not a function. So I'm going to do a couple of vertical lines here. There's one, it only hits once. There's another one, it only hits once. There's another one, it only hits once. If I do one over here, doesn't look like it hits, but this graph continues. It would hit right here, so it only hits once. So this passes the vertical line test, therefore it's a function. Now, another relationship is the y equals plus or minus the square root of x. And that's made up with two separate functions, the square root of x and the negative square root of x. The square root of x, if we remember, we just take the square root of some x values, 0, 1, and 2, because the square root of 0 is 0, 1 is 1, and 4 is 2. Negative square root, we take the square root and then make our answer negative, so we just beat these numbers with the negative. And we end up with a graph that looks like this. 0, 0, 1, 1, 4, 2. 0, 0, negative 1, negative, or sorry, 1, negative 1, and 4, negative 2. That looks like a sideways parabola. I missed my dot. But you get the picture. So to determine if this is a function, we can do the vertical line test. If I do the vertical line over here, it doesn't hit, which is okay. If I do the vertical line here, it only hits once, that's good. If I do the vertical line here, it hits twice. And as soon as it hits twice, it fails the vertical line test. Therefore, it's not a function. So again, as long as it fails once, that makes it not a function. And if it doesn't hit at all, that's still okay. It can still be a function, but it's if it hits two or more times. If it hits once, it's fine. That's it for functions. We have one more review topic left, and that's transformations of a function, 0.3. Thanks for watching. Remember, there's some good practice questions for 0.2, so give those a shot if you're willing and able. Otherwise, I'll see you for 0.3.